reactants here, as I'd mentioned yesterday. The issue is mainly, I think, just getting mixed up here with what it means to be a reducing agent. So a reducing agent gets oxidized. Oxidized means it loses electrons, which means that it becomes less negative. So in part A, we've got Fe2+. It's actually having to gain electrons. So it's being reduced, but it is not the reducing agent. And that goes in A and B, because even if we look at just oxidation numbers, it's going from +2 down to 0, so it's being reduced. Same thing in C. The only place where the oxidation number increases as if it is being oxidized and losing electrons is in D. Same kind of a thing here. If something is losing electrons, so as H2S forms the S, what happens to the sulfur atoms? Well, we're going from a -2. Oops, that's the wrong tool. We're going from a -2 to a 0. Okay. In that case, there, its oxidation number is going up, which means it's becoming less negative, which means it's losing electrons. And so and then you have to know, of course, definition there as well, and so B is correct there. Moving on to C, in this case, the copper in copper-2 oxide, it's 2+ here, and it's 2+ here, and it's 2+ afterwards, which means it is neither oxidized nor reduced, because the oxidation number wouldn't change. Okay, again, I mean, this is, yeah, lots here. Same kind of an idea. And here as well. We're looking for oxidation, loss of electrons. And so I've put down B here, and unfortunately D still isn't correct. But in this case, the only one that's losing electrons is going to be C, actually. And so that one is going to be, in this case here, because the oxidation number is going upwards. So it's being oxidized, which means it's losing electrons. It's becoming less negative. Okay, this one here, very well done. Okay, you did catch on here, it's oxidized. And then just for fun, or not, you had to look back a little bit to last unit and say, is it endo or exothermic? The delta H for this particular compound for tin 2 oxide is negative, which means it's got to be exothermic. In a reaction tin 2+, and you have to look at that one there, and then you have to answer it correctly. Now, it will not always act as an oxidizing agent. You'll find it on both the oxidizing agent side and the reducing agent side. So it cannot be C, and then you just have to figure out which ones it'll work with. Nickel is a reducing agent, so it could act as an oxidizing agent. It might not be spontaneous. Will undergo oxidation. Again, it would still be acting as a reducing agent. And then here will act as an oxidizing agent when combined with cadmium, and that's the one that works out. Okay. Oxidizing agents in redox reactions are always reduced, which means they gain electrons, and decrease in oxidation number. Definitely don't always contain oxygen, so it leaves us with C. Redox reaction occurs when an iron nail, I like the way that you're going around putting your chemical symbols in there. This one here, hard to tell in the scan. I think it does say copper 2+. Very well done with that. Okay. This one here, again, works out nicely. Okay. Spontaneous reactions, and so here again you're just looking, and an idea that you might want to look at would be adding something and saying, okay, in this particular solution we have Ag plus, in this one we have Pb2 plus, here we've got mercury 2 plus, here we have aluminum 3 plus, and here we have chromium 2 plus. And that might help make them easier to find on that chart on our reducing agent. So let's try that again on our standard reduction potential chart. Okay, very well done here. Definitely I can tell that there's no issues with those types of questions. Redox reactions are those in which, now actually this is a sign that we don't have a redox reaction. Number of valence electrons remains the same. That and actually A and B are saying the same things. And D, ions are rearranged. That would be like a double replacement, and actually in double replacement reactions there's no transfer of electrons, and that's what we're really left with, is C. That is what we're looking at, is a redox where there is a transfer of electrons. Okay. Very well done here and here. In this case iron has a greater tendency to be oxidized than copper. Basically what we're saying is that copper is a weaker copper metal, I should say, is a weaker reducing agent than iron. If you look on your table, what you'll find is that copper as a solid is higher up that list than, more towards the top than iron is, which means of course that iron is more likely to react with more things. Although C may be true, the chemical part makes B a better answer. Okay. In redox reactions, you got that correct. That's just a definitional thing. I like how you crossed off some of the ones that were not correct. This is a goofy looking question because it's not with anything real in terms of compounds, and so it's just a matter of taking a look here and seeing, okay, what's going on. And it is just unfortunately a matter of reading carefully and knowing your definitions. And so if M is oxidized, again, Leo the Lion says grr, so we would have excuse me, for A, loss of electrons would be oxidation, which means that the other thing on that same side gains electrons. In fact, and then if we look here, if M loses, N is oxidized. Well, no. If it's a redox, it means there's something is being oxidized and something is being reduced. But here we're saying M is losing electrons, which is oxidization, and N is also oxidized, so that doesn't work. Same kind of thing here. If M is reduced, it means it is the oxidizing agent. And then on D, if M is the reducing agent, which means it is oxidized, then N, they can't both be oxidized. Okay. So reduction is when an oxidizing agent gains electrons. Gain of electrons is reduction. Conversion of bromine gas to bromide ions, again, it's gaining electrons, it's becoming more negative. Formation of gold ions from gold metal, it's actually having to give up either 1 or 3 electrons depending on which gold ion is forming. Alright, on this one here, the reduction half reaction, again we're looking here at the gain of electrons, and so what's gaining electrons there? And it is going to be A. We could also in this case look at oxidation numbers as we were talking about in class yesterday, where this would be 0, this is -1. That's being reduced already. Alright, This one here. Alright, here's the thing you'll want to look at, and I'm going to not give you too many hints. I'll get you to look in your notes and make the correction on this one. And in fact, on this particular second quiz especially, there's a lot more of the numerical response, and any of those ones that are incorrect, if you make the corrections, I will change the mark on those. Okay, so check. I would check just your definitions here for number 1. There's a couple I noticed with the salt bridge or porous cup where there was, you had in both cases said that it's allowing electrons to move. It's actually allowing ions to move. So in this case, I'll leave that alone for this question, sorry. Reduction potential for this, you got that correct. Alright, and this particular one, correct answer is going to be D. And the big thing with this one is that these are both given as the reduction half reactions. Now in the case of this cell working, we're going to actually have the lithium as the solid lithium as our starting material. And so what we've got is, you're absolutely right, this would be your oxidizing agent, this would be your reducing agent, but when we balance it, we have to have 4 electrons gained and 4 electrons lost. And so the correct answer is going to be D. Alright, so here it was just a matter of figuring out which of these is actually gives more than 1.25 volts. Very well done. This one here is one of those questions that on diploma exams they like to throw at you. And this particular question is actually, now that I look at it, more of a last unit, a Unit D kind of question, even though it does have some crossover into electrochemistry. And so C would be correct. I made that a bonus question. It didn't count for or against you. Chlorine gas, again, would be produced. This goes with the same thing as this question up here. You have to flip the chlorine one, and so you've got chloride being turned into chlorine gas. So that, yes, that's true. It's produced. Yes, it's spontaneous. Because your oxidizing agent here is higher up the list than your reducing agent. pH decreases. Well, in fact, no, the pH is going to increase because we're using up H+, which means it's becoming less acidic. And the concentrations of chlorate, of this stuff, yes, will decrease, but of chloride is going to... Sorry, these ones will both decrease, sorry. Because again, when we flip this, both chloride and chlorate are used up in the reaction. Okay, so again, this one here. Here you want to look at, again, just your definitions of being oxidized is different than being an oxidizing agent. What I will say in this particular one is write out the reaction equation. So we've got acidic solution of nickel 2 nitrate. Identify your oxidizing agent and reducing agents. I'll leave it there. Okay. Very nicely done. I see that the problem from the first quiz where you've identified this as a reducing agent being oxidized is correct. Okay, this is the separator, works just like the porous cup. It provides or allows the ions to move. Okay, very well done with this one. Okay, so this is one that you'll have to look at. I did show a little bit of work there, and I'll just leave that there for now. Very well done here as well. This is one of the tougher questions on here. Also very well done. Also very well done. Yup, again. This one here, correct answer is C. because we have to look at moles of electrons. So 200 grams, you are correct, is 3.06 moles of zinc. Look at your half reaction. So we've got Zn2 plus 2 moles of electrons. So and we're looking here for moles of electrons. So you have 2 moles of electrons for every mole of this. So you're going to just multiply by 2. Now with this one here, what we've got here is the charge on the unidentified metal ion is 3 plus. You're going to have to divide by 3 because once here you've got moles of electrons, you're going to have to divide by 3 or multiply by 1 over 3 to get moles of metal. And I'll just leave that where it is because it'll have to get changed as well. Purified copper sheets act as the cathode. That part is correct, but the cathode in this case is going to be where the copper 2 plus ions are reduced. Okay, the oxidizing agent is reduced at the cathode. That's the Leora-Garowac thing. Okay, this one here, there's a little hint I did give you on the sheet. Very close to being completely correct. Just be careful with mole ratio stuff again. Okay, very well done with this one here. Again, some of these are definitely the trickier types of questions, and you are on top of those, and I think it's just a couple of definitional things will make a huge difference. Okay, cars started. When you start the car, it's acting as a voltaic cell. The battery is providing the energy. You leave it running to recharge the battery. In that case, it acts as an electrolytic cell. Very well done with 22. Okay, 23 showed some of the work here. You have 0.34 minus whatever your x value is going to be equal to 1.80 because again the copper 2 plus, excuse me, that is your oxidizing agent minus the reducing agent. End up with that. It's going to have to be negative 1.46. Okay. In this case, we're setting nickel as 0. Nickel itself is normally, anyways, a negative number. And so now what we're looking for is the difference in electrode potential between nickel and bromine instead of between nickel and hydrogen. Right now, hydrogen is 0, so you'd say nickel minus, so the nickel, which is 1.07, minus the hydrogen would be 0. You have to look at nickel now. Sorry, bromine minus hydrogen would be 1.07. And then when we get to the second one here, we're saying no, it's actually going to be bromine now minus the nickel one, and you end up with 1.33.